See this question. This question is given in GATE, I think GATE 2003. So this question is given in GATE 2003. You please read that question once. I'll just explain the question and I'll try to solve it. You read it once, okay? Now they are saying that there are two processes P and Q, and one process is like this. So a process P has a forever while loop. It is an infinite loop, and it is continuously going to do this print 0, print 0. And then process Q is going to be in the infinite loop and is going to continuously print 1 and 1, right? And now they have given labels W, X, Y and Z. These labels are used to insert the synchronization statements, which means this S and T are mutexes, and synchronization statements can be inserted only at W, X, Y and Z, which means they are saying that we are supposed to put W, X and Y and Z at this point some synchronization statements. What are synchronization statements? That down and up on semaphores. Here they are mutual this binary semaphores. Then which of the following will lead to an output starting with 0011 0011 0011? So they have given all the options, 4 options, and now if you try to place those synchronization statements there, they are asking which of these is going to give us the output 0011 0011 like this, okay? Now let's see what happens if I put each one of them there. So the best way to solve it is you don't try to put anything there. You take each option and try to put it there, and then you solve it. You don't come up with a solution. You take the option and then check it whether it is verified or not. You don't try to form any solution here. Okay. Now the first one is, see this, A. At W if I put P of S, and at Y if I put P of T. So let's put it there. See, option A is at W they are putting P of S, which means down on S, and then at X they are putting V of S, and then at Y they are putting P of T, and then at Z they are putting V of T. Fine. And both are initialized to 1, which means S equal to 1 and T equal to 1. So what happens if I try this? So we have to see that the only sequence which is possible is 0011 0011 so on, right? Now if both are 1 and 1, and if P is waiting on S and Q is waiting on T, then anything can go first, which means either you can go with P first or Q first, or you can start with P and run it till middle and then start with Q and run it till middle. Therefore there is no guarantee that we always start with 0 0. The simple way is, the simple contradiction is you could start with P of Q, isn't it? And then you can print 1 1, right? Why? The reason is process Q is waiting for only T, and T is initially 1, therefore Q will never get blocked, right? And here 1 1 will print, which means one sequence possible is 1 1, and then maybe even after that it will even print 1 1, or it can go to 0 0. Therefore 0 0 1 1 is not the only possibility. Yes, 0 0 1 1 is possible, but then it is not the only possibility. They are saying that which will start only with this. So you have to say that which of the following will lead to an output starting with this. We should start only with this, not with anything. But here 1 1 is also possible. Therefore A is not the option. Now let's look at B. Now what B is trying to do is P of S at W and V of T at X. Here instead of P of S, V of T, right? And then P of T at Y, which means here is same, and then V of S at here, which means here it is V of S, right? And then initially S is initially 1 and T is 0. S is 1 and T is 0. This is given. Now let's see what happens with this. Now see this, only S is 1 and T is 0. So anyone who is waiting on T will never enter the loop, right? Will never try to, will get blocked. So since S equal to 1, there is only one possibility here, right? P can enter this, P can cross W and enter this and print 0 0. Even if Q tries to enter this and print 1 1, that will get blocked at this point because P of T will block it. The reason is T is initially 0, right? Therefore only possibility is 0 0, we can print it first, right? And then after that V of T. So once V of T is enabled, then T will become 1, then only Q will enter, right? Now once Q enters, then only 1 1 will be printed, and only after Q finishes, then again S will be made 1, right? and therefore again P will enter, P will start. So here there is strict alteration possible. Since S equal to 1 and T equal to 0 is given, only beginning possibility is 0, 0, and moreover after this P is over, even if it tries to enter one more time, it will get blocked because it has to wait for someone to do V of S. And who will do V of S? Only the Q, right? And when will it do? Only after doing 1, 1, right? Therefore, strict alteration is possible here and the required sequence is possible here, 0, 0, 1, 1, 0, 0, 1, 1. So this is the answer B. But still we shall examine what happens with the others. Now other one is at S P of W P of S and at X V of T. Yes, and at it is same. Only thing is they are making S and T as 1 and 1. This is the case, right? If S and T is 1 and 1, then the problem is either P can start first or Q can start first, and even they can even jumble, right? Which means one sequence possible is like this: Q can start first, which means it can print 1, 1, right? And then P can start, which means 0, 0. Therefore, this is not the only possibility. Other possibilities are also there. Even one more other possibility is both of them can start simultaneously and enter this, right? So 1 we can get 0, 1 starting, or you can get 1, 0 in the beginning. Therefore all the possibilities are there, so it is not the one. Got it? So it is not the option. Now what about D? D is saying that P of S at W and V of S at X. Here it is V of S, okay, and then P of T at Y, okay, and V of T at Z. So it is V of T at Z. And then they are saying S equal to 1 and T equal to 0. When they say S equal to 1 and T equal to 0 here, now let's see what happens. If this is the case, then first thing is only S can, P can start because it is waiting on S. Yes, P can start and it will try doing 0, 0, and immediately it can go back and again come and again print 0, 0 because it is entering and then again it is making it as up. It is making down and then up, down and up. Therefore it will enter it, print 0, 0, and again enable it, and again go and enter it, keep 0, 0, and then enable it, right? So 0, it is possible, 0, 0, 0, 0 is possible, which is not of this form. And one more worst thing is this Q will never enter it. The reason is Q is waiting on T, and there is nowhere anyone is trying to do up on T. So any number of times Q try to enter it, it will still get blocked. The reason is no one is actually trying to make it 1. See, if this would have been V of T, then there is a chance that Q might enter this. But then since there is no one who can make this as 1, only Q is trying to make this as 1, but then in order to go here you should first enter it, right? And you are even blocked here. So unless you reach here, you cannot reach, you cannot cross this point. But unless you cross this point, you cannot reach here. Therefore Q will never get executed. So only output possible because of this is all zeros, right? So the option is B. Got it?